Hi everyone, we are talking today about the first 4 pages of the notes for the trigonometric functions unit. So we talked a little bit about some of this yesterday. I'm going to skip over the special right triangles part and jump straight into talking about angles and radians. All right. An angle is formed when two rays that have a common endpoint are rotated. We label that angle with theta in degrees, but we can also talk about the arc length that's created between those two rays when an angle is formed. That's called a radian, and we'll talk about that in a little bit. For now, though, I want to talk about review that there are 360 degrees in a circle, therefore 180 degrees in half of a circle, 90 in a quarter of a circle, and 270 degrees in 3/4 of a circle. We have 2 different ways to talk about degrees. We can talk about them as a decimal. So, for example, 37.425 degrees. Or we can talk about them in degrees, minutes, and seconds. 37 degrees, 25 minutes, and 40 seconds, for example. The calculator does a lovely job of making that conversion. If you type in 37.425 into your calculator, double check that your calculator is in degree mode by hitting the mode button, which is up here underneath the screen somewhere in the center of the calculator. Scroll down, make sure it's in degree mode, and you're all set to go. You type in 37.425 and then go to the second apps button. You'll see it says angle above. Scroll down, you'll see the degree symbol, the minute symbol, and the second symbol is a little tricky, but we'll find that in a minute. Go down to where it says DMS. You can take the decimal degree that you type in, 37.425, go down to degrees, minutes, seconds, and you will get 37 degrees, 25 minutes, and 30 seconds. It's that easy every time. Now to go the other way, to go from degrees, minutes, and seconds to decimal degrees, it takes one more extra keystroke. You're going to type in 36, and then go to second apps to angle, hit the degree option, then 40, again second apps angle, go down and hit the minutes option, and then you type in 32, and then hit the alpha key, and then down here in the lower corner of the calculator, lower right-hand corner, you'll see 2 little hash marks, and that stands for seconds. So that's the keystroke for getting the seconds. You hit equals, and you should get 36.68 degrees. Okay, now we're going to talk about radians. We're going to talk about the distance along the arc of a circle, along the outside edge of a circle, so the length of an arc that's created when I make a rotation of those 2 rays and form an angle. 1 radian is equal to the length of the radius that gets wrapped around the circle 1 time. So 1 radian is 1 radius that covers the arc of that circle on the outside. How do we figure out how many radians are in a full circle? Well, we could estimate, but it turns out that we don't have to. We have a formula for figuring this out. The circumference is equal to 2 pi times the radius. Well, if I'm going to take a radius of 1 unit, then I'm just left with a circumference of 2 pi. So what that means is that if I'm taking a radius of 1 unit, whatever that unit is, I've always got 2 pi radians around my circle. So 0, if I start here, 0 radians, but if I make a full rotation and I put the full length of that radius around the circle, it turns out that it'll go around 2 pi times. Well, what's that? That's approximately 6.28 times, because remember pi is 3.14. What that means is that if I have 2 pi radians in a full circle, I'm going to have pi radians in half of a circle, and I'm going to have pi over 2 radians, half that distance, in a quarter of a circle. And in 3/4 of the circle, I'm going to have, well, 1 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2 radians, 3/4 of the way around the circle. On the next page, we're going to talk about radian measure in two ways and how to convert from pi notation, which is one option, to decimal notation as the other. If you're given 1, the simple conversion is to multiply by this fraction equivalent to 1 of pi over 180. We determined in the last slide that there are 180 degrees in pi radians and pi radians in 180 degrees. So we've got a fraction that's equivalent to 1, and you know from other classes or other math classes that when you do a unit conversion, you want to multiply by equivalent fractions so that the units that you want to cancel end up in the numerator and denominator. So we multiply by an equivalent fraction of pi over 180, and we get 42 pi over 180, which if I divide each of those by 6 is equal to 7 pi over 30. You could further that by multiplying 7 times pi on your calculator and then dividing by 30, and you would get the answer in radians. But leaving it as 7 pi over 30 for now is just fine. Now, to go the other way, from radians to degrees, you want the radians to cancel. The radians are in the numerator here, so you're going to multiply by that same fraction, but flipped over. You're going to multiply by 180 over pi. Again, that's a fraction that's equal to 1. The pi's will cancel, and what you're left with is 360 divided by 3, and degrees, divided by 3, and that's going to equal 120 degrees. So converting between radians and degrees is quite simple. You're going to multiply by that fraction of pi over 180 or 180 over pi, depending on what you're given and what you want to cancel. We're going to skip the section on bearing and navigational angles for now. That could be an aspire to situation for you if you're curious about it. And we're going to talk about how to find arc length when you're given the radius and theta, or if you're given arc length, finding the other, finding the missing piece. If you're given 2, finding the third. So the formula is that S is going to be equal to the radius times theta, where theta is in radians. So you might have to do a little bit of that conversion that I just showed you in order to get theta into radians if it's given in degrees, but we'll do a few examples. Number 1, I don't know what S equals. I know that R is equal to 4, and I know that theta is equal to 12. I can tell it's in radians because there's no unit on it. There's no degree on it. So following this formula, S is going to be equal to 4 times 12. My units are in inches, so the arc length is going to be 4 inches. That's the length of the radius, times 12 radians. So that means I'm going to go around 12 times, and that's going to be an arc length of 48 inches. In number 2, I've got now that S is 18, the radius is 3 meters, and I want to find out what theta is. Well, it's a matter of dividing here. If theta is attached to the 3 by multiplication, I undo it with division, and so I've got 6 radians in this situation. In number 3, I know that the radius is, that the arc length is 10 centimeters. I don't know the radius this time, but I do know that theta is equal to 24 degrees. Well, since theta has to be in radians in order to talk about the arc length, I need to convert 24 degrees into radians by multiplying it by pi over 180 degrees. Again, the degree units cancel, and what I'm left with is 24 pi over 180. If we divide that by, let's see, we can divide both by 6. We get 4 pi over 30. Divide that by 2 once more, and we get 2 pi over 15, which when we multiply that out, 2 times 3.14 divided by 15, we get some number that would give our answer, in radians, but right now, 2 pi over 15 is a perfectly fine answer. Okay, so now I'm going to talk about a sort of practical, or put an application piece to this. I've got a piece of pizza. The perimeter of a 60-degree slice, of a large 7-inch radius pizza. So radius is 7. I want to find the arc length, S. I've got to convert 60 degrees to radians. So I'm going to multiply that by pi over 180, cancel the degrees, and get 3 pi over 2 radians. Okay, so I've got that my S is unknown. The radius is 7 inches, and the and theta is 3 pi over 2. What I've got here is 21 pi over 2 as an arc length, right? So just reviewing that a little bit, I want to know the arc length, S. These two sides of the pizza are 7 because that's the radius of the pizza, and I've got a 60-degree slice, but I needed to convert that to radians. So when I take that formula, S equals R times theta, my theta became 3 pi over 2, my arc length I don't know, and my radius was 7, and I multiply all of that out. I've got now an arc length of 21 pi over 2. You can convert that to a decimal and add it to 7. Okay, we are now, I'm going to skip the angular to linear speed section, and we're now back in special right triangles. The next video will be all about the unit circle.